Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. So let's look at question 9. So it says in an electrolytic cell below, two carbon rods are used as electrodes, and a concentrated copper chloride solution is used as an electrolyte. Guys, the importance of using copper rods is that they are inert. Okay, what does inert mean? They are chemically inactive in a reaction. So we do not want them to interfere with the reaction. Okay, we do not want them to interfere with the reaction. They just serve as a connection between the source, sorry, the source as well as the what, as my electrolyte. And then now I always say this, that the electrolyte here, CuCl2, will break up now to Cu2 plus, and then the Cl will break up to Cl minus, but now we need two of them because it can provide two atoms. This one can accept two, I mean one atom, so we need two of those. I hope it makes sense. And then now we are not giving the polarity of the battery. So there will be some information that we get. So it says now, but by the way, the reaction is going to be between copper and now chlorine gas. When the cell is operating, a gas is released at electrode S. So at electrode S, if the gas is released, that gas will be Cl2, because remember Cl minus and Cl2 have a very beautiful relationship. So it means here when Cl2 is released, it means Cl minus undergo oxidation. Why am I saying it undergoes oxidation? Because its oxidation number moved from Cl minus to Cl0. Remember, Cl, if it is just a pure element, is going to have 0. So its oxidation number moved from minus to, from -1 to positive to 0. No, there is no positive 0 to 0. So its oxidation number increased. Again, so now, and we are told that we are forming what? Chlorine. So in this one, oxidation occurs in ox. This is our anode, and then it means this one red cat will occur reduction, and this is our cathode. But what are we? So what are we trying to form in here? We are trying to form what? We are trying to form copper. We are trying to form copper. Okay. Since well we know this is an ox. Remember, in a electrolytic cell, this one is positive, and then this one is negative. Cathode is negative, anode is positive for electrolytic cell. And then it means electrons will move from here. Remember, they move from positive all the way here. So, and remember again, the cations move to the cathode. So it means now, let me swap this. Okay, so it means now the Cl minus will now meet the electrons that are coming in there. So it means the Cu2 plus will meet those electrons that are coming there, and they will form as pure copper like that. So yeah, okay. Oh, and then while electrode T covered with a brown layer. Why is it covered with a brown layer? A brown layer tells us that there was a formation of what? There was a formation of copper. Okay, remember copper is just a brown layer. So there is going to be an increase in the mass of the cathode. Why? Because we are trying to form. Remember, I always say this: we are forming at the cathode. Whether we are talking about reduction, so galvanic or electrolytic, we are always forming. Okay, forming at the cathode. This we are not forming this one, Cl2. Write down half cell the half cell to explain the observation made at electrode S and electrode blah 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 blah. For electrode S, so we already know this is C, but it needs to be balanced, guys. So we have 2 here, so it's gonna be 2 here, and then it's gonna be 2 there. Okay, you can use your reduction table. It's fine. 2 Cl minus gonna be Cl2 plus 2 electrons, and then this one is gonna be Cu2 plus 2 electron to form copper. Guys, don't make a mistake of using this copper. Don't make a mistake of using that one as leaf. Which electrode, S or T, is an anode? Okay, guys, we have already mentioned that an anode, which what electrode? So it's going to be electrode S. Why? Because Cl minus is oxidized there. Let's say because Cl minus undergoes oxidation there. It undergoes oxidation there. Okay, or you can say A, A. Cl undergoes oxidation at S. Okay, or you can say oxidation occurs there. Okay, oxidation occurs there because Cl minus undergoes oxidation at S, or oxidation occurs there. You know what I mean? And then we are given another information that says to us a current of 2.1 2.1, okay, a current of 2.5 amps passes through the cell for 5 hours. Calculate the what? The total charge that flows through the cell. Remember, we have this formula that says Q is equal to I change in time. Then our current, it is 2.5. But now what about our time? Our time is going to be 5 hours multiplied by 60 minutes multiplied by 60 seconds. Remember, our time we always want it in what? In seconds. So we're going to say 2.5 multiplied by 5 multiplied by 60 multiplied by 60, or 2.5 multiplied by 18,000. It's just 45,000 watt coulombs. This is a charge. Okay. And then they say calculate an increase in mass of the cathode. Increase in mass of the cathode. Remember, I said that the cathode we're gonna be forming what? Copper. Now there will be an increase in the copper gear. So how can we do that? So first thing first, we need to see, okay. Uh First thing first, we'll need to convert the charge to number of electrons. We'll need to see the number of electrons that are gained in here. Okay, the number of electrons that are transferred to that part. How can I do that? It means I will need to say this is me answering 9.3.1, sorry, 9.3.2 rather. So I'm gonna say, okay, I need number of electrons. Number of electrons is equal to q divided by number your number of electrons is equal to q divided by E again, and then q, it is 45,000 as we have seen. And then one electron has 1.6 times 10 to the power of negative 19. And then the number of electrons that we get, it is something like 2.8125. 2.8125 times 10 to the power of 23. These are the electrons. Okay? These are the electrons that were... So those are the electrons, right? So I will need to do what now? I will need to say, okay, let me convert these electrons now. These are the number of electrons. Let me convert to these number of electrons to number of moles of electrons. Okay, what do you mean? I want to convert these electrons to number of moles of electrons. Using what? Using this formula. Number of moles is equal to number of particles divided by Na, where this one represents the number of particles. Particles can either be electrons, atoms, and etc. etc. Okay, so okay, I'm gonna say number of moles, okay, of electrons are gonna be 2.8125 times 10 to the power of 23, all divided by Avogadro's constant. We know that to be something like 6.02 times 10 to the power of 23, and then it beautifully gives me an answer of Let me quickly punch that on my calculator. 2.8125 times 10 to the power of 23 divided by 6.02 times 10 to the power of 23. It gives me an answer of something like 0.4672 what moles. These are now the number of moles of what? Of electrons. Okay? Number of moles of electrons. Let me do this. Number of moles of electrons. These are the number of electrons. Okay? Number of charged electron. Okay, if I may put it like that. And then number of moles of electrons are these. But now remember, we are trying to calculate the what? The what? The increase in mass of the cathode, and the cathode is my what? Is my copper. Okay, so I will need a mole ratio between the number of moles of electrons as well as the number of moles of copper. Can you see that for every 2 moles of number of moles of electron, there is 1 mole of what? Of copper. Okay, so then what? Then it means now for me to convert from number of moles of electrons to number of moles of the copper that I'm looking for, I'm going to say number of moles of copper, it is half the number of moles of the electrons, because the ratio it is 1:2. This is 1 and that is 2. So it means it's half, copper is half of this one and this one is double of that one. Okay, so it's going to be half and then 0.4672. And it will give me a beautiful answer such as 0.23, I'm going to say 0.4672 divided by 2. So it's going to give me an answer of 0.2336 moles. Now that I have number of moles of copper and I want mass, I can say number of moles it is equal to mass divided by molar mass, where number of moles of copper now are said to be something like 0.22, 336, and then the mass of copper is what I'm looking for. What is the molar mass of copper? The molar mass of copper, it is 63.5 as per our periodic table by our Dimitri Mendeleev, our father. And then mass of copper is gonna be 0.2336 multiplied by 63.5, and then it gives us something like 14.83 grams. So this is what now I get. Okay, so you can get a range, but yeah, this is what I get. And then now we are done. Let me take a quick recap. We first found the what? The charge. Okay, and then we now convert our charge to number of electron. Okay, where is that charge? So here it is. We now convert this to number of electrons. Can you see number of electrons? Okay, and then we take those number of electrons, we convert them to number of moles using the Avogadro's constant. Remember, this can refer to number of electrons, number of atoms, number of molecules. Remember, this is number of particles. Okay, so I'm going to convert my particle, or my rather electrons, to number of moles. So I do that by dividing by my what? My Avogadro's constant. And then, but I see, okay, I do not necessarily want the number of moles of my electrons. Okay, but rather I want the number of moles of my copper. So I need to use my mole ratio between my what? My copper and my uh, electron, copper and electron. So I know that, okay, for electron to copper, there is 2:1. So for every x of this, there should be x divided by 2 of that. Hence, I'm saying, okay, here, if for number of moles of electron are this much, for copper, there should be half of those. Hence, I say 1 divided by 2 of that. And then after finding the number of moles now of my copper using mole ratio, I can now beautifully come to this formula and say number of moles equal to mass divided by molar mass, and then I get my mass to be equal to that much. Okay, so it is something like 24241, 5 marks. So that is that, guys, for 5 marks. I hope it was understood, the question. And then the last one, the carbon rods are now replaced with the copper rods. Okay, remember, guys, we need carbon rods because they are inert, they do not react. But now when they replace them with copper rods, these ones are chemically active. They are not inert, these ones. Say, so it means if I have an electrode An electrode that is made of copper, well, it's gonna interfere with the reaction, so it's gonna undergo some reduction or oxidation depending on the strength of it. So it's chemically active, so it's gonna be active in the reaction. So they say no gas was released, okay, when they were observing electron S, and its surface appears rough and corroded. So can you see now? It tells me that my copper interfered with the reaction. It reacted thereof, and then it started being corroding thereof and started releasing its roughness more, as says. And then they say refer to the relative strength of reducing agent and explain this observation. The observation, which observation? Why gas is no longer appearing on S. Why gas is no longer appearing on S? Okay? It's because now, it's because now these are now replaced by copper. They are no longer carbons. Okay? These are now replaced by copper. So it means this copper will want to find a position with what? With this Cl. Okay, what position, Mpo, if you may be specific? Now, this copper and this one, this pure copper and the Cl minus, let me put it like this. The copper, pure copper, and Cl minus will want to fight for the position of saying who will now, remember by the way, this is still an the anode, who will now undergo oxidation between the two of us. Okay, because this one it was copper and it will always be copper. So which one will undergo oxidation between us? Okay, so we need to refer to the strength of the what? Of the reducing agent. Remember, reducing agent, it is the one that is oxidized. So we want to see between copper and Cl minus. Okay, remember initially it was Cl minus with an inert carbon. The carbon does not react, hence the Cl minus was free to do whatever it does. But now it has Cu, which is chemically active. Again, remember I said we use carbon because they are chemically inactive. So copper is chemically active. So now between copper and Cl minus, which one is gonna be now a stronger reducing agent? We now go to our table and say, let me check between copper, okay? Let me check now between copper and Cl minus. Which one is the stronger reducing agent? Which one is the stronger reducing agent? Here is my Cl minus. And I see that the strength of the reducing ability or the strength of reducing agent increases as I go up. So it means as I move from my Cl minus to my copper, the strength thereof does what? It increases. The strength increases. What does this mean? It means now copper is a stronger reducing agent than what? Than Cl minus. So it means now. And by the way, guys, when they say compared to the strength of reducing agent, you're gonna compare these ones on the right. When they say strength of oxidizing, you're gonna look at these. So can you see now copper is a stronger reducing agent than Cl minus. So we're gonna say copper. Okay, let me answer the question here. I'm gonna say copper is a stronger reducing agent than Cl minus, and Cu will be the one that will be oxidized. Oxidized. You can say oxidized to Cu2 plus if you want to. Okay, so first thing first is that copper is a stronger reducing agent than what? Than Cl. Okay, Cu is a stronger reducing agent than what? Than Cl minus, not just Cl. And then copper will be the one that will be oxidized. Okay, okay. So if copper is the one that is oxidized, it means now my Cl minus will no longer be oxidized to Cl2. Hence why there's no formation of gas. There's no gas released. And rather there is what? Copper there is a corrosion that occurred there. Its surface appeared rough and corroded. So hence now the copper corroded to what? To copper 2 plus an electron. It was oxidized. So that's why. I hope it makes sense. One can say Cl minus is a weaker reducing agent than Cu. I repeat, Cl minus is a weaker reducing agent than Cu and will not be oxidized. If you are weaker, you will not be oxidized. And then now let me answer the last question, 9.4.2. It says now this cell can be used to be for the purification of copper. Which electrode, S or T, will be replaced by impure copper during this purification process? Okay, so the one that will be replaced by impure copper during purification process is gonna be the what? Is gonna be the S. Why S? Because the impure will be in here. Let's say the impure is copper, silver, and platinum. So the impure will be at the anode. Okay. So whatever that wins the position of being oxidized will now be formed at the cathode. Okay. So remember on the cathode we are forming. So whatever that you are trying to purify, so the copper that you are trying to purify will be formed in here at the cathode. So the impurities should be put rather on the anode, and then oxidation will occur on the stronger reducing agent. So copper is a stronger reducing agent than Ag as well as Pt. So it will be the one that undergoes oxidation and form now copper at the what? At the cathode. So we're gonna say electrode S. In this particular case, the off electrode S. So yes, guys, yes, that's how we answer these questions based on what? Based on electrolytic cell. Hopefully you enjoy them. Thank you.